In this final video of our class, what we're going to talk about is if we take a conic section and take the axes and rotate them. So in the previous videos, we talked about the most general form of a conic being ax squared plus cy squared plus dx plus ey plus f is equal to 0. So what we're going to do now is just include this xy term, which what that's going to do is actually rotate the x and y axis. So if b is equal to 0, the xy term does not appear and the graph has a vertical and horizontal axis. So that's the case that we did in the previous conic section videos. But now, if b is not equal to 0, so if it appears, the xy term appears, and this means that the axes have been rotated by some angle theta. Okay, so what we tend to do with these kind of equations is we want to get rid of the xy term. Okay, so first we find out what angle our axes have been rotated by, and then we eliminate that xy term so that we can see actually how to graph it on our new rotated set of axes. Okay, so for your test, this is what I'm most worried about, is can you find the angle that we rotate the axes through, and also can you distinguish between the different kinds of conic sections? And we'll talk about that in a little bit. So this formula is very important. Okay, so that's always the first thing you want to do before you eliminate the xy term. Okay, and so what's going to happen is you're going to have two different axes going on. So you have little x and little y, and then once you rotate it, you'll have big X and big Y. And your book actually calls this x prime and y prime, but to simplify our work, I'm just using a big X and a big Y because the primes tend to get really messy when you're writing all of this. So to eliminate the xy term, so maybe I should say xy is your normal axis, so your regular axis. And then big X and big Y are your rotated axes. So there are specific formulas that we use to get rid of that xy term so that we can actually figure out how to graph our equation. So little x is equal to big X times the cosine of theta minus big Y times the sine of theta. Little y is equal to big X sine of theta plus big Y cosine of theta. Big X is equal to little x cosine of theta plus little y sine of theta. And big Y is equal to negative little x sine of theta plus little y cosine of theta. Okay, so those are the formulas we're going to be using, and actually these first two are really more important. So these are the ones that actually take away that xy term. And so basically once you sub in these formulas, it's just a lot of algebra to get your equation into a form that we like. Okay, so let's practice first by just talking about a single point. Okay, so if the coordinate axes are rotated through theta is equal to cosine inverse of 4/5, we want to find the big xy coordinates of the point with little xy coordinates -2, 3. Okay, so first of all, I need to find big X, which is equal to little x cosine theta plus little y sine of theta. And I also need to find big Y, which is negative little x sine of theta plus little y cosine of theta. Okay, so those are the two formulas I'm going to be using. All right, now my angle theta is equal to the cosine inverse of 4/5. Okay, and you should probably notice that 4/5 is not a cosine that you find on your unit circle. So this is one of those cases where we would need to draw a triangle. Okay, and we're not super interested in what theta is, but given the fact that we know the cosine is 4/5, we know that the adjacent side is 4 and the hypotenuse is 5. So using Pythagorean theorem then, we know that that opposite side is 3. So now that we have a triangle, we can find any trig function we need to find. So rather than knowing theta, we know the cosine of theta and the sine of theta. Okay? So now that we have this, we can just go ahead and plug this into our formula. So for big X, we know that little x and little y are -2 and 3. So we plug in -2 for little x. We know the cosine of theta is 4/5. And then little y is 3. And the sine of theta is 3/5. So now we just need to simplify. So we get -8/5 plus 9/5, which is 1/5. Okay, so on your rotated axes, you would just use an x-coordinate of 1/5. Okay, and this will make a little more sense later when we'll do a graphing example. Okay, so for big Y, we need to plug in little x, so we have -2 times the sine of theta, which is 3/5, plus y is 3, and cosine of theta is 4/5. So now we just need to simplify. So let's see, that's +2 times 3/5, that's 6/5, plus 12/5, which gives us 18/5. Okay, so on your rotated axes then, the point big X, big Y will be equal to 1/5, 18/5. Okay, so that would be your point. All right. So now let's look at an equation. So we've done a point. Let's actually look at an equation. So we want to determine the equation of the conic 2x squared plus y squared minus 4y is equal to 4 in big XY coordinates when the coordinate axes are rotated through theta is equal to 60 degrees. Okay, so first of all, let's write out what little x and little y will be equal to. So little x is going to be big X times the cosine of 60 degrees minus big Y times the sine of 60 degrees. Okay, and if we wanted to simplify this, we know that the cosine of 60 degrees is 1/2, so we get 1/2 times big X minus square root of 3/2 times big Y, because the sine of 60 is square root of 3/2. So if we wanted to simplify this a little bit more, we could factor out a 1/2, and so we get 1/2 big X minus the square root of 3 times big Y. Okay, and you might be wondering why we factored out the 1/2, and my answer to that is it will make our work a little bit easier when we actually plug in little x and little y. So now let's find little y. So we know that this is big X times the sine of 60 degrees plus big Y times the cosine of 60 degrees. So this comes out to be square root of 3/2 times x plus 1/2 times big Y. And so again, if we factor out the 1/2, that will give us square root of 3 times big X plus big Y. Okay, so notice we have two really similar expressions for x and y, and so now what we're going to do is actually sub those into the equation. Okay. Alright, so let's sub this in. So our original equation was 2x squared plus y squared minus 4y is equal to 4. So what we're going to do is everywhere you see a little x, we're going to plug in our expression for little x, and everywhere you see a little y, we're going to plug in our expression for little y. So what we get is 2 times, our expression for little x is 1/2 times x minus root 3 times y, and that's going to be squared, plus y is 1/2 times the square root of 3 times x plus y, and that's going to be squared, minus 4 times our expression for y again. Okay, and that's equal to 4. Alright, so now all we need to do is just simplify this. Okay, and so be really careful when you're multiplying out all of these binomials because it can get a little tricky. So let's start by squaring these things. So we get 2, and if we square the 1/2, we get 1/4. And then if we square that binomial, we get x squared minus 2 root 3 xy plus 3y squared. Plus, now if we square the 1/2 again, we get 1/4. And then we get 3x squared plus 2 root 3xy plus y squared. And then in the last term, we can multiply 4 by that 1/2. So we get negative 2 times root 3x plus y is equal to 4. Okay? So now all we need to do is just keep distributing and add together some like terms. So if I multiply the 2 by, well actually, yeah, let's multiply the 2 by 1/4. So we get 1/2 times that trinomial now. We have x squared minus 2 root 3xy plus 3y squared plus 1. We can go ahead and distribute this 1/4 through, so we have 3/4 x squared plus root 3 over 2xy plus 1/4 y squared minus 2 root 3 times x minus 2y is equal to 4. Okay, and the last thing I need to do is just distribute this 1/2 through, and then we can add some like terms. So we get 1/2 x squared minus root 3 xy plus 3/2 y squared plus 3/4 x squared plus root 3 over 2 xy plus 1/4 y squared minus 2 root 3 times x minus 2 times y is equal to 4. Okay, and I know this looks complicated, but I think the terms will all add together pretty nicely. So first let's look at the x squared terms. So we have 1/2 x squared, and we also have 3/4 x squared. So if we add 1/2 to 3/4, we should get 5/4. So we'll have 5/4 x squared. Now let's look at the xy terms. So we have negative root 3 xy, and we also have root 3 over 2 xy. So if we were to add root 3 over 2 to negative root 3, we should get negative root 3 over 2 times xy. Alright, so now that we've done the xy terms, let's look at the y squared terms. So we have 3/2 and we have 1/4. So if we add 3/2 to 1/4, we should get 7/4 y squared. Alright, now let's look at our x. So we only have one term that has an x and one term that has a y. So we'll just leave that the same. And that's going to be equal to 4. Okay, so notice what we've done here. So now we have an equation that has a big X and a big Y. Now it's important to notice that because our original equation did not have an xy term, our transformed equation does have an xy term. However, it is important to note that normally our original equation will be the one with the xy term, and we'll use this process of subbing in a little x and a little y to get rid of the xy term so that we have our equation in a more user-friendly form. So now let's look at how to classify these most general forms of our conic section equation. So this is the other really important part that I actually will test you on. So remember, it's finding the angle of rotation and also being able to figure out which conic section an equation describes. Okay, so in the equation, the general form of a conic, we want to look at the quantity b squared minus 4ac. And that might sound familiar to you. If you remember the quadratic formula, that's negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you remember doing that back in algebra probably, we use that quantity under the square root to determine how many solutions a quadratic equation has. Okay, and that was called the discriminant of the equation. Okay, So this is strangely the same thing. So we're looking at b squared minus 4ac. That's also called the discriminant of the equation. And so what this is going to do is, whether you get a positive number, a 0, or a negative number, is going to tell you what kind of conic section you have. Okay, so using this idea, the graph of the equation is either a conic or a degenerate conic, and on the test, of course, I would give you an actual conic section. I wouldn't trick you with that. But in the non-degenerate cases, the graph is a parabola if that discriminant is equal to 0. We get an ellipse if it's negative, so b squared minus 4ac is less than 0, and it's a hyperbola if it's positive, so if b squared minus 4ac is greater than 0. Okay, so that's a pretty simple way, I think, to tell whether you have a parabola, an ellipse, or a hyperbola. So on the test, I would give you like a general form of an equation and say, classify the conic using the discriminant. Okay, and so what you would do is figure out what b, a, and c are, plug it into b squared minus 4ac, and then tell me what kind of conic you have. And like I said, for the test, we're going to assume that all the conics I give you are true conics and not degenerate cases. So you don't have to worry about being tricked by that. However, in the theory question, I could ask you what are the 3 types of degenerate conics. I think that's fair enough. Okay, but for the formula's sake, assume that you have true conics. All right, so let's look at some examples of this. So now we're going to get into some graphing and actually see what's happening with these rotated axes. Okay, so I'm going to zoom out a little bit because we're going to need a bit of room for this. Okay, so for the first one, we want to use the discriminant to determine whether the graph of the equation is a parabola, an ellipse, or hyperbola. We want to eliminate the xy term, and then we want to sketch the graph. Okay, so this is going to be a pretty long problem. So the first thing we want to do is classify the equation. Okay, so to do this, we use our discriminant. So we have b squared minus 4ac. Now in this equation, a is 1, b is negative 2, and c is 1. Okay, so what we get is we get negative 2 squared minus 4 times 1 times 1. So we get 4 minus 4, which is 0. So this tells us we have a parabola. So on a test, you need to first evaluate the discriminant, but then make sure you tell me what this actually is. Okay, so it's not enough to just say that the discriminant is 0. What does that mean? Okay, that's what I'm worried about. All right, okay. Now, before we eliminate the xy term, let's figure out how much our axes are rotated. Okay, so this would be the other part of a question on your test. So for the angle of rotation, we want to go back to that formula that was at the beginning of the notes. So we had the cotangent of 2 theta is equal to a minus c over b. Okay, so we want to plug in a, c, and b. So we have 1 minus 1 over negative 2, which is 0 over negative 2. Okay, so cotangent might be kind of hard to think about, so let's flip this and think about tangent. So this means that the tangent of 2 theta is equal to negative 2 over 0. Okay, and so we've got a situation where the tangent does not exist. Okay, and we know that the tangent does not exist when your angle is pi over 2. So even though we have a 0 in the denominator, that actually tells us that the inside of the tangent is equal to pi over 2. Okay, and this is the same thing as taking the tangent inverse. It's just not very good practice to take the tangent inverse of something that's over 0. Okay, so we're just going to say that 2 theta is equal to pi over 2, And so if we divide by 2 here, we get that theta is pi over 4. Or you could say that that's 45 degrees. Okay, and I'll specify on the test whether I want you to use radians or degrees. Okay, so our angle of rotation is 45 degrees. Okay, so now let's work on eliminating the xy term. So now we're going to eliminate xy term. Okay, so the first thing we need to do is get our expressions for little x and little y in terms of big X and big Y. So we know that little x is big X times the cosine of our angle of rotation minus big Y times the sine of our angle of rotation. Okay, so this is going to be square root of 2 over 2 times big X minus square root of 2 over 2 times big Y. And so if we factor out the square root of 2 over 2, we get that that's square root of 2 over 2 times x minus y. So that's the expression for little x. Little y, on the other hand, little y is big X times the sine of pi over 4 plus big Y times the cosine of pi over 4. So if we evaluate this, we have the square root of 2 over 2 times big X plus the square root of 2 over 2 times big Y. And so that's the square root of 2 over 2 times x plus y. Okay, so now that we have our expressions for little x and little y, we can plug this into our equation. So let's start with our original equation. So we had x squared minus 2xy plus y squared minus 2x plus 4y is equal to 0. So if we plug in x and y, we get the following. So we have square root of 2 over 2 times x minus y squared minus 2 times square root of 2 over 2 times x minus y times square root of 2 over 2 times x plus y plus y squared is going to be square root of 2 over 2 times x plus y quantity squared minus 2 times square root of 2 over 2 times x minus y plus 4 times square root of 2 over 2 times x plus y, and that's going to be equal to 0. Okay, so yes, this is very complicated, and that's why I'm not having you do this on the test. But it's important to see how this applies to actually graphing these things. So let's work on simplifying this. So if we square the square root of 2 over 2, we get 1/2. So we have 1/2, and if we square that binomial, we get x squared minus 2xy plus y squared. Okay, now for the second bit, we have negative 2 times the square root of 2 over 2 squared, so we have negative 2 times 1/2. And if we multiply x minus y times x plus y, we have x squared minus y squared. Okay, if we square that y squared, then we get plus 1/2 times x squared plus 2xy plus y squared. And then if we do negative 2 times the x, we get negative root 2 times x minus y. And then plus 2 root 2 times x plus y is equal to 0. Okay, so let's keep distributing here. So we have 1/2 x squared minus xy plus 1/2 y squared. The 2 and the 1/2 will cancel, so we just get minus x squared plus y squared. And then we distribute the 1/2 through that next trinomial, so we get 1/2 x squared plus xy plus 1/2 y squared minus root 2 times x plus root 2 times y, and then plus 2 root 2 times x plus 2 root 2 times y is equal to 0. Phew, okay, that was a lot. So now let's work on adding like terms. So the first thing you might notice is we have a minus xy and a plus xy. So that is exactly what we wanted to happen. So in this step where you add all of your like terms, everything with an xy should cancel out. And that was the whole point of going through this whole rigmarole of plugging in x and y and simplifying. Okay? So let's look at the x squared terms. So we have 1/2, we have -1, and we have 1/2. Okay? So if we add all of that together, they're going to cancel out. So 1/2 and 1/2 would give us +1, and then if we subtract the 1 off, it's negative. So the x squared terms are also going to cancel out. And that's allowed because remember that we classified this as a parabola. So one of these squared variables is going to cancel out, and we found out that it's x. Okay? So let's look at our y squared terms. We have 1/2, we have 1, and we have 1/2. So 1/2 plus 1/2 plus 1 is going to give us a +2. So we have +2y squared. Now let's look at our x terms. We have -√2 and 2√2. So if we add -√2 to 2√2, that'll give us a +√2 times x. And finally, if we add our y terms together, we have 2√2 plus 1√2, which gives us +3√2 times y. And that's equal to 0. Okay? So notice what we did here. So this is our eliminated equation. Okay? So notice the xy term is gone. So now, even though we have some kind of nasty numbers with the square root of 2 and everything, we can actually get this into a form that we can graph. Okay? And that's the whole object of this. So let's keep going a little bit more and try to get it into standard form so that we can actually graph this parabola. Okay? So the first thing I'm going to do is keep my y's on one side, and I'm going to move the x term to the other side. So we get 2y squared plus 3√2y is equal to -√2x. Okay, so now I'm going to factor out the 2. So we get 2 times y squared plus 3√2/2 times y. We're going to add something there when we complete the square, but I don't know what it is yet. Is equal to -√2 times x. Okay, so now let's decide what number we're going to add there. So if we take the square root of 3/2, we take 3√2/2, and we divide it by 2, we're going to get 3√2/4. Now if we square that, we're going to get 9 times 2/16, which is 18/16, which is 9/8. Okay, so the number we're going to add here is 9/8. And the number we're going to add to the right side will be 2 times that, so we'll get 9/4. All right? Okay, I think that was the hardest part. Now let's just go through and simplify a bit more. So if we factor down this trinomial, we get y plus 3/2√2. So all I did there was square root the 9/8. Quantity squared is equal to -√2x plus 9/4. So remember standard form, we put the, we want to get this 2 to the other side because it goes on the side where the variable is not squared. So what I want to do is divide 2 over, so I get y plus 3/2√2 squared is equal to -√2/2x plus 9/8. Okay, and the last thing I need to do is just get x to have a coefficient of 1, so we need to factor out -√2/2 from the right side. So my equation in standard form is y plus 3/2√2 squared is equal to -√2/2 times x minus 9√2/8. Okay, so that is the equation in standard form. And again, while the numbers are not very nice, I understand that, this is graphable. Okay, So let's get some decimal approximations, just so we can guesstimate where these go. All right, so 3 over 2 root 2 is approximately negative 1.06, and I'm writing it as a negative because remember when we have a plus sign inside of the parentheses, that actually tells us that the y-coordinate of our vertex is a negative number, okay? Root 2 over 2 is approximately negative 0.707, okay? So because that's negative, we know that it's going to open to the left, okay? And we know that it's a sideways parabola because y is the variable that's squared, okay? And finally, 9 root 2 over 8 is approximately 1.591. So again, because we have a negative this time inside of the parentheses, we know the x-coordinate of our vertex must be a positive number. So I'm just going to write down the vertex approximately. So this is approximately 1.591, negative 1.06. And you're going to see why this is important when we graph next. Okay? So let's draw our graph. So I know that was a lot of work, but I promise we're almost done. So third part, we're going to draw our graph. Okay? So first, we're going to draw an XY axis like you always draw. Okay? So this is little x, this is little y. So now I'm going to switch colors just so you can see the difference. Okay? So we found earlier that our axes were rotated 45 degrees. So big X and big Y, imagine rotating these axes 45 degrees. Okay? So the y-axis gets rotated 45 degrees and the x-axis gets rotated 45 degrees. Okay? So this line here is going to be big X, and this line here is going to be big Y. Okay? And the angle between the old axis and the new axis is going to be 45 degrees, or pi over 4. Okay? So hopefully that kind of makes sense. All right? So what we're going to be graphing on, though, are the red axes. Okay? So we want to mark off the red axes to draw our picture. Okay, so I know my vertex is only at 1.5, negative 1, so I'm going to draw my dashes kind of big here. Okay, so I might have 2 on each side there. Okay, so let's put in our vertex. So on the red axes, I'm going to go positive 1.5 and down 1.06. So maybe that falls about right there. So it's in between 1 and 2 on the red x-axis, but it's a little past negative 1 on the red y-axis. Okay, so my vertex might be about there. Okay, and we know that it opens to the left. So if you flip your paper, I think it's a little bit easier. So if we then graph a left-facing parabola, I'm not too worried about exactness here, but if we were to graph a left-facing parabola along the red axes, we might get something like that. Okay, so notice what's happened here. You're graphing the parabola the same as you always have, except now we're graphing it on a rotated set of axes. Okay, so it's no longer on your normal XY axis like you're used to. It's been rotated some angle. Okay, and so that's the whole point of this section. But again, what I'm most worried about for the test is, can you classify the equation and can you find its angle of rotation? Okay, so for the next example, we're not going to go through this whole mess again. We're just going to find the type of conic section and we're going to find the angle of rotation. Okay, so let me switch back to blue real quick. Okay, so for the last example, we have 14x squared plus 8xy minus y squared plus 6 is equal to 0. So first, let's classify the equation. So again, to classify, use your discriminant. So b squared minus 4ac Okay, so in this equation, b is 8, a is 14, and c is -1. So we have 8 squared minus 4 times 14 times -1, which is 64 plus 56, which gives us 120. Now, what's important here is not the fact that we got 120. What's important is 120 is positive. So 120 is greater than 0, which tells us that we have a hyperbola. So if you get a discriminant that is positive, your graph is a hyperbola. Okay? So now let's find the angle of rotation. Alright, so our angle of rotation, we use the formula cotangent of 2 theta is equal to a minus c over b, which is 14 minus a -1 over 8, which is 15 over 8. Okay, so we have tangent of 2 theta then is equal to 8 over 15. Okay. So this is an instance where you would need to use your calculator because 8 over 15 is not a tangent value on your unit circle. Okay, so in the calculator, you would type in tangent inverse of 8 over 15, and you should get some decimal in degrees now. So calculator in degree mode. Okay. On the test, I'll probably ask you to do this in degrees because radians can be kind of confusing. So when you type in tangent inverse of 8 over 15, you should get something that's really close to 28 degrees. Okay. Now, if 2 theta is 28 degrees, then theta is going to be 28 degrees divided by 2, which is 14 degrees. Okay, so that is our angle of rotation. Okay, so notice what we've done. We've classified the equation using the discriminant, and we've also found the angle of rotation. Okay, so these are the only 2 things that I'm going to ask you from this section on your test. Alright, so it's important. However, we did graph in the last example only because I wanted you to see how big XY and little xy are related. Okay, so if you have any questions with this section, please ask me. Okay, this is not easy stuff. Alright, but hopefully the stuff that I'm going to put on the test is understandable.